In this segment, we're going to take a look at two masses connected to a frictionless pulley, and we want to calculate the acceleration. Now, we begin by drawing a free body diagram. So the larger mass M, capital M, will have a longer vector, and that represents its weight. And the little mass M will have one that is shorter. There's tension in that string, and I'll draw that arrow actually smaller than mg. It's smaller if you look carefully, and both those tensions are the same. So we label it. We have mg acting down, and that's the greater force. We have an opposing force upwards of the tension in the string, and it's exactly the same tension in the other string. And then we have little mg. Now we draw this, we label it. Now to find the acceleration, the best approach is to look at the big picture. Let's take big mg, and we will subtract little mg. That's the net force acting, and it will equal the total mass that's being accelerated, m plus m, times a. Now we just put in the numbers. Capital M is 0.244, and g, of course, is 9.8. And, of course, once you've done this, you'll take your calculator out and work this out carefully. Little m is 0.2, and again, g is 9.8. And the total mass is the sum of the two, and it will be 0.444. And I'll write that down. And we multiply then by a. So it's a very simple matter of solving, and you take your calculator and you'll find that a equals, work it out, and you will find 0.971 meters per second squared. Now we're asked a kinematics question. We know the acceleration, and they want us to find the distance that it will fall in order to reach a certain speed. So we write down what we know. From the previous part of the question, the acceleration was 0.971 meters per second squared. We know that it started from rest. The question tells us that. And we know that it reaches a speed of 0.8 meters per second. And the question is, all right, at that speed then, what distance did it fall? And you have to learn to say, oh yes, this is a kinematics question. I can do these. So it's which equation works. And we find that Vf squared is equal to Vi squared plus 2AD. This seems to be the one that works because it has all the unknown, or the unknown plus the three givens. The Vi cancels out. It starts from rest. And therefore, d is equal to Vf squared over 2a. Now, this is pretty easy to calculate out. So have your calculator and try this. We have 0.8 squared. Don't forget to square it. A very common mistake. And notice it's 2 times the acceleration is 0.971. A lot of students, I think, right away want to put in 9.8. But remember, this system is accelerating downwards at 0.971. And when I run that through my calculator, I'll give the answer to two significant figures because it's 0.80, that's 2 sig figs. I get 0.33 meters. Finally, we're asked to find the tension in the string. Now, this part's very easy. What we will do is, again, we will just isolate the one mass and have a very simple equation. We draw the free body diagram, and we will look at this mg, the large mass, and the tension. And we look at that one simple little F equals ma situation. It's accelerating downward. The equation is quite simple. Big mg is the larger minus the smaller, t, equals big M A. Each one of these we know. We put the numbers in, 0.244 times 9.8. and we minus t, which is our unknown. That's what we want to find. And that is equal to, again, 0.244. And the acceleration from the previous parts was 0.971. Well, I run that through the calculator, and I find that my unknown t is equal to, when I round it off to two significant figures, it will be 2.2 newtons.